Okay, so this is teaching, we're talking about teaching science at home, and I've put teaching in quotation marks because especially the older your children get, the less teaching you will be doing, and the more you will be learning science right along with them. You know, when I homeschooled my daughter, I knew all about science, but I knew virtually nothing about history and geography and that sort of stuff. So while many homeschooling parents are busy learning science and maths, I was busy learning history and geography and government and things like that. So we all have things that we learn right along with the students we're educating. So some of you might be learning science right along with them as well. And just like before, I've got notes available for this talk, so you can go to my website and download notes. And I'm on Facebook. Somehow that didn't make it in here, but I am. Okay, so homeschooling, I think, is an ideal setting to teach science. And I know that goes against sort of the conventional wisdom. Most of the conventional wisdom is you need a school with an expert teacher with laboratory facilities and so forth to really learn science. But I honestly think home is the best place to learn science for lots of reasons. And the first reason is your child gets to learn science for the right reason. And the right reason to learn science is not promoted very well in our schools. What's the right reason to learn science? Well, let's talk to a real scientist, a serious scientist. Blaise Pascal, and if you don't know him, at the ripe old age of 14, he published his first paper, and in it he broke new ground in the field of geometry. So at the ripe old age of 14, he was discovering new geometric facts that no one had figured out before. Just because he wanted to help his father, who was a merchant, do the books easier, he invented an adding machine, a mechanical adding machine, that eventually became the slide rule, which eventually became the modern calculator. So we probably wouldn't have had the calculator except for him or someone like him who invented that mechanical adding machine. If you're forced to take physics in detail, you'll learn about Pascal's law, which talks about how pressure is transmitted through fluids. So he was a really important scientist, really certified genius. Here's what he says about science. Nature has some perfections to show that she is the image of God, and some defects to show that she is only his image. And he said, this is why I study science, because I feel like through science I can learn a little bit more about the Creator. And his view is not unique among either, especially among the scientists who wrote the science we're doing today. So if you don't know Carolus Linnaeus, he's the founder of modern biology's classification system. When you learn kingdom, phylum, class, order, family, genus, species, that's him, right? Here's what he said about his scientific work. This was put at the beginning of a compilation of some of his most important scientific work. He said, I saw the infinite, all-knowing, and all-powerful God from behind. I followed his footsteps over nature's fields and saw everywhere an eternal wisdom and power and inscrutable perfection. So in his mind, science was the process of following God's footsteps. You know, and that is the motivation that brought us most of the science we know today. And there are still some modern scientists who understand this. So Henry Fritz Schaefer III, and his friends call him Fritz, but I'm not his friend. So Henry F. Schaefer III, I admire him quite a bit, but I don't know him personally. He is the second most quoted chemist in the world. So we have this thing in science called the Science Citation Index. I call it the Science Ego Index. Because what you can do is you can look up a person's name, and you can see how many times he or she has been cited in the scientific literature. So if you look at his name, there's only one chemist in the world who's cited more often than him. So obviously this guy knows a little bit about science and how it's done. Here's what he says. The significance and joy in my science comes in the occasional moments of discovering something new and saying to myself, so that's how God did it. My goal is to understand a little corner of God's plan. And honestly, I think that's one of the best descriptions of what science is. Science is learning a little corner of God's plan. So in my mind, that's the reason you do science. You do science because what you're studying is something created by your Father. And if you want to know your Father a little better, obviously the most important thing to do to know your Father better is to read the Scriptures. But if you want to know your Father even better, you study His handiwork, because His handiwork tells you about Him. And I don't think this is unscriptural. In fact, if you look at Job 12:7 through 10, This verse, for a long time, it sort of bothered me. So it starts out this way, but now ask the beasts and let them teach you, and the birds of the heaven and let them tell you. Now I live with two beasts. I have two cats. All our cats are named after scientists. So this one is Curie and the other one is Sophie. These cats, one of them especially, Curie, will sit in the door to my office and just start yowling. Just wow. And I always ask her, what can I do for you? And you know what? She never answers me, except with another wow. So I don't know how a beast is supposed to teach me, right? But the scriptures say, let the beast teach you. Or speak to the earth. I've actually met people who think they can speak to the earth. And let it teach you. And let the fish of the sea declare to you, who among all these does not know that the hand of the Lord has done this, in whose hand is the life of everything and the breath of all mankind? How do we ask the beasts? How do we allow the fish of the sea to teach us? How do we speak to the earth and let it teach us? The way we do that is we study them. If we study them, we understand a little more about God. So that's the reason we study science. Science is more than an academic exercise. It's a spiritual exercise. And as odd as that sounds in today's society, please understand this was the motivation for the vast majority of scientists. I've been writing an elementary series that deals with the history of science, or at least presents science in a historical framework. And I am just amazed at how almost every one of the major figures of science was doing it to learn more about God. And oftentimes their motivation for their scientific ideas were from the Bible. So for example, Copernicus, most secular scientists will tell you that Copernicus sort of was the first to disregard the Bible because he took the sun and put it in the center of the solar system rather than the earth. And people reading the Bible thought the earth was in the center of the solar system. And Copernicus was the first to ignore the Bible and see the data and put the sun there. That's actually false. Copernicus himself, in his book, tells us why he put the sun there. And he says, because the geocentric system with earth in the center is just far too messy. There are all these exceptions you have to play with and things. When you put the sun in the center of the universe, it becomes much more orderly. And since God is, quote, the most orderly workman of all, end quote, he would create the most orderly solar system or universe, is what Copernicus said. So anyway, in the end, it was his idea of what the biblical God is that took the sun and put it in the center of the solar system. Not some departure from Scripture. It was his motivation was scriptural. And you see that over and over again in the great scientists of the past and some of the scientists that exist today. So science is more than just an academic exercise. It's a spiritual exercise as well. And in home, we can teach it that way. In school, obviously we can't. We should, but we can't, right? Also, in homeschool, your child's scientific education is bounded only by his or her interest and talent. In the end, when you've got a child who especially is really gifted in the sciences and so forth, they are routinely held back in their classroom because the classroom is teaching towards the middle, and this leaves the people who are struggling behind, and it also bores the people who are really good. So in the end, this classroom sort of limits where your child can go scientifically, but if your child is good at this, he or she can go crazy in the sciences and do incredible things because the child can spend an enormous amount of time and, exercising his or her interest. So, as Cron.com tells us, students in science class diligently memorize human cell components like DNA, mitochondria, and endoplasmic reticulum, and most disturbingly, say a growing number of scientists, they learn to hate science. And that's really true. Because they're asked to memorize, I was speaking to somebody who's a veterinary professor here, and he said, my students, if you give them a test of 30 questions that are asking them just to regurgitate facts, they can do that real well. You ask them to solve a problem, they can't do it, right? Because this is what school does. Memorize human cell components. Memorize what the mitochondria and the endoplasmic reticulum do. Memorize those things, but don't ever think about it, right? As Chron.com says, real science is exciting. It's completely different from these textbooks. And these textbooks, of course, are talking about, public school textbook. And that's a real problem. In class, you're doing all this memorization and stuff when real science is about thinking and working through problems. And you can do that if you're at home. There was a study of homeschooled families in the U.S. by Jay Hornick. And he showed, especially in the teen years, parents don't teach their children science. They don't. The students learn it on their own. They teach themselves. And according to this study, here's what happens. The result was, quote, inquiry science of the very highest quality. The students performed as real scientists. They explored scientific issues, made hypotheses, did experiments, and analyzed results. Compare this to the memorize, regurgitate approach we see in most schools. This is what science is really about. Because you think about it, Diana Waring, who's another homeschool speaker, she tells this story about her son wanted to know, how can steel ships float? Steel's heavier than, heavy enough to sink. You throw a chunk of steel in the water, it sinks. So how can a ship made of steel float? And the mother, Diana, said, I have no idea, but we should be able to find this out. So back then, this was the ancient days, so they didn't have the internet they didn't have Mozilla to pop up and start typing at Google in. So in the end, what they do, they went to the library, and it took a long time, but they figured out why steel ships float, right? And her son, from that, started understanding things like density and all these other factors that go into buoyancy. And so in the end, because they figured it out together, they both learned it, first of all, but because they figured it out, it was a much more personal, they learned it better, they remembered it better because they worked it out on their own rather than just being told why, right? And that's a real key, inquiry-based science. So, one thing I think homeschoolers worry about a lot is, what if I can't answer my child's questions? They're using this resource for science and they don't understand it. I can't answer it. What do I do? Then you guys look it up together. You work it, you research it, you figure it out, especially with Google and things like that. It's a lot easier than it used to be. But the very process of figuring it out and trying to research it and find out on your own makes it a much more valuable lesson. And what you're teaching them is what to do when I'm gone and I'm not there to answer your questions anymore, right? And most schools never teach what happens when the teacher goes away. How do you keep learning? Homeschool can teach that, especially in the sciences. Here's an example of how a student is completely unbound by restrictions and so forth. Brandon Brown, he's a fellow who used to work for me for a while. By the time he was 16, he had his life figured out. He loved politics, and of course, who doesn't? He loved politics, loved arguing politics. He worked on several politicians' campaigns when he was younger and so forth, and he decided he wanted to be a politician. So he was going to go to university, study law probably, political science maybe, but probably law, get a degree, and start start campaigning for political office and be a politician. Now, while he was in homeschool, he did well in science. He got A's and B's, but he didn't like it very much. And he loved being a politician. So he knew by age 16 he's going to be a politician. His mother made him take a chemistry course at 16. He didn't want to. He said, I hate science, and if I were in public school, I'd be done. Because in the public school in his state, you had to take 2 sciences in high school, and that was it. And he had already taken 2 as a high school homeschool student. So his counselor, his school counselor, had he been in school, would have said, oh, you don't like science? Well, you're done. You don't have to take anymore. You've fulfilled our obligation. I can put a check mark in that box, right? But his mother said, no, we're doing better than the public schools. So we're going to try to make you take science every year, whether you like it or not. So he took chemistry, and he ended up loving it. He hated physical science. He hated biology. He loved chemistry. Who knows why? Who knows why? But he loved chemistry, and so he found that interesting enough that he decided, well, people say physics is a lot like chemistry, so I'll take physics. He liked physics. He figured out he liked chemistry more. So he decided that between the chemistry and physics, he liked it all so much that he ends up liking science. He just didn't like what he had studied before. So remember, he had it all figured out. He was going to be a politician. After taking 2 science courses, he decided to go to university and study chemistry instead. Now, my point here is, in school, he would have never taken the chemistry class, first of all. And secondly, up until 16, he had no idea that he liked this stuff, right? But once he decided he liked it, he learned it like crazy, right? Because that was what spoke to him. That was where his talent was. So in the end, he really learned that well. So he graduated with a chemistry degree, and then he went on to medical school. And he went on to medical school. He got his MD, and he's a practicing physician. He's actually a radiologist these days. But 1 degree wasn't enough for him. So he also got a master's in philosophy along the way, because he wanted to keep the politics a little bit in his mind. So he got a master's in philosophy so he could write on bioethics. So he's a practicing physician, but he's also a published author in bioethics. So in the end, this kid at 16 had it all figured out. He just had it all figured out wrong, right? But in the end, the reason he was able to turn himself around and do what obviously his talents are, what the Lord wants him to do, is because he was in a situation where he could do that. And in school, that wouldn't have worked. But here's the most important thing. His father is an accountant, and his mother never went to university. Yet they produced a guy who went on to university and then went on to medical school and got an extra degree along the way. That's what homeschooling is all about. If homeschoolers were bounded by their parents' ability, that would be sad for them. But these guys would have never produced a medical doctor who's also a published bioethicist. That just wouldn't happen. But the fact is, our children aren't bound by our limitations. And we do this as parents, naturally, and somehow people worry that we can't do this as homeschoolers. So for example, when we adopted Dawn, I found out that young women had this magical ability to turn on tears. And those tears could reduce me to just a pile of quivering goo. So whenever she wanted to get away with anything, all she had to do was produce the tears. And I would honestly let her do anything. But my wife was utterly immune to these tears, right? So guess who the disciplinarian was in our household? Wasn't me, right? So, most people, and remember, I was the main person doing the homeschooling. So in most houses, it's wait till your father gets home. No, for me, it was wait till your mother hears about this. That's what it was like. But that's what we do as parents. We make up for our weaknesses. I recognized early on I'm not so good at discipline. So I'm going to find somebody who's better at it than me, right? We can do exactly the same thing in homeschooling because as parents, we don't want our kids to be limited by us, right? And so we do it naturally as parents. We should be able to do it as homeschoolers as well. So in the end, you don't have to worry about how good you are in the sciences. All you have to do is, are you giving your child the resources and the environment so he or she can take his talent, if it happens to be science, as far as it can go? And this kind of education pays off greatly at university. I told you before, my university students that I had were head and shoulders. If they were homeschool graduates, they were head and shoulders above the rest. And studies show that. So this is a study from the U.S. There's a similar study done in Canada. I don't know of one done in South Africa yet. But I expect when it's done, eventually it'll be the same. So this is the University of St. Thomas in the U.S., and it's a Roman Catholic university. So they actually split their students into 4 categories. The students came from public school. The students came from a Catholic school, which is high schools run by the Catholic Church, private non-Catholic schools, and then homeschools. And if they look, basically, if you look at anything, the homeschoolers are cut above. So this is their first-year grade point average, how well they did their first year. And I think this is the best indicator of how prepared they are for university, because your first-year grade point average is when, it's really testing how ready you were for university. Notice the public, Catholic, and private schoolers, all forms of normal school in the U.S. produced roughly the same level of academic achievement. But the homeschoolers were just a cut above. By 4 years, there was a little bit of differentiation between the public, Catholic, and private schools, although I honestly think all of that's within the margin of error of the study. So really, these guys are all equivalent again. But once again, the homeschoolers were better. Not as much better as they were coming in. And I think that says the homeschooled students were better prepared coming in, but the other students were able to get used to the university after a while and do a little better relative to the homeschoolers. But then look at the rate at which they graduated in 4 years. The homeschoolers were way above everybody else in graduating in 4 years. And you typically find this. If you look at grade point averages of students in most universities, you find that the homeschooled students, on average, have higher grades, do better, have a better chance of graduating. If you look at homeschool graduates who are adults now, they're more likely to have a university degree in the U.S. than those who didn't go to homeschool. So I think that's because this kind of study, this kind of education where you're not spoon-fed everything, where there's not a teacher who can answer every question, where you're forced to figure some of this out on your own, that's actually a better education. And so in the end, you produce better students, better university students. All right? Canadian universities, when asked about their homeschooled students, said they have performed well at the university level. They are often overachievers. Most of them are involved in extracurricular activities. And this is, because of this worry, many universities have this worry. We're going to get this homeschool kid who has never seen another kid in his life before, right? Because that's what homeschoolers are like, right? If they've seen any other kid, it's just a family member, right? They've never seen any other children, right? And there are universities who think that way. And so one of the things most universities look at is, well, how involved are these poor, isolated homeschool kids? How are well involved? Well, they're involved just as well as everybody else, really. They have lots of parental support. And once again, this is a natural extension. When you make learning a lifestyle, when it's all of us learning together, that doesn't stop when they go to university, right? They're used to leaning on you for some help. So they'll talk to you about, well, here's what's the... And for me, my daughter chose to go to a university that was only about an hour away from us. So for me, that translated into going there once a week and helping her when she took statistics, because otherwise she just wouldn't have gotten through statistics, So I just continued homeschooling, only it was now dorm schooling, because I went to her to help her. And that's very common. You think about most parents who have never done homeschooling. If their child calls them and says, I'm having trouble in chemistry, what would most parents do? Can you find a tutor? But that's not what most homeschooled parents will do. Most homeschooled parents say, well, I've been doing this for a few years already. I could probably find some resource to help you or, something. So in the end, I think you're going to be better prepared to help your children through university, and certainly that's what the Canadian universities found anyway. Generally, they are more independent and require less assistance, and I think that's honestly because a lot of that assistance is coming from the parents anyway. So they're require less assistance from the university as a whole. And they tend to do better. So this is now the University of Toronto. Their grade point averages, their homeschoolers, all their homeschoolers together, every student they could say, here's a homeschooler. The range was 2.74 to 3.96. The university's average was 2.2. So even the lowest scoring homeschool graduate was above average, right? And this is real common in the U.S. We do these studies where, we say, what percentage of homeschoolers score at or above the national average on these standardized tests? And the answer is 90%, right? So even if you're a lousy homeschooler, you tend to do better than the public schools. And I think that's what a lot of folks who are thinking about homeschooling may not understand. It doesn't take a lot of work to do better than the public schools. It really doesn't, right? It may take a lot of your work, but it doesn't take a lot of skill. Because that's how bad the public schools are. And that's true in lots of countries. Not every country is like that. South Korea is just the opposite. South Korea kids are killing themselves because they don't pass a test. It's the high pressure, so people in South Korea are homeschooling to get away from the pressure. But in most other countries, homeschoolers are, one of the reasons they're homeschooling is to produce a better education for their children. Right? And I think that's true in the U.S., and I think that's true in South Africa as well. So, with all of that under our belts, with the pep talk out of the way, the question is, how do we do this? How do we help our children learn science at home? One of the most important things to understand about science is mathematics is absolutely necessary. especially in the early years, and I'm going to harp on this, math is actually more important than science. Alexander the Great once said, diplomacy without arms is like music without instruments. I say that science without math is like music without instruments. You can't have one without the other. Because mathematics teaches you a way of thinking that is directly applicable to science. The problem is, when in science, you can't use that level of thinking until you've collected a lot of facts. So in science, it takes you up until maybe 12, 11, 13, something around there, to be able to start really thinking scientifically. You can start collecting facts real early in your life, but really to think scientifically, you've got to have a certain level of cognitive ability. But with math, you start learning math right away. And that trains your mind to think scientifically. There's a real cognitive link between the two. Now, please understand what I'm saying. I am not saying a student needs to be good at math to be good at science, because I know a lot of scientists who are not good at math. As a matter of fact, talked about Einstein in my first talk. He readily admitted that mathematics was his worst subject. And in fact, there are some historians, now I have to tell you, I don't believe this, but there are some historians who say it was actually his wife who did all the math related to his theories. And his wife was a math teacher, so that's possible. But I don't think people like this have proven their case. But he admitted mathematics is his weakest subject. Nevertheless, he understood how important it was, so he took every math course his university offered. When he got his first professorship, he noticed that university offered a few more math courses, so he took those as well. And at the time, that was unheard of. At the time, there was this big separation. Professors were up here and students were down here, and they didn't mix. But he sat with the students and took these classes because he understood, even though he wasn't good at it, he needed to be experienced with it because it trained his mind, right? So that's what I'm saying. A student doesn't have to be good at math to be good at science, but he has to be experienced at math to be good at science because of this way of thinking, all right? So that's really important. Like I say, especially in the primary years, it's more important than science. If you haven't done much homeschooling yet, if you talk to somebody who has, there are days where you simply try to get something done, and that's enough. You've been in those days, right, where you just have to just get something done. You're not going to get everything. You're just going to get something done. So in those days where you have to start saying, okay, we're not going to worry about this, we're not going to worry about this, don't worry about science that day. Make sure you get the math done. That's the most important thing in the primary years. But how do you do this in the primary years? First of all, you be involved. Especially, it's true throughout, but the more you can be involved with your children, the more likely they are to learn it well and be at least moderately enthused about it. Keep it light, but not simple. So you want to teach real science, but you don't want to teach it so heavy yet. There's going to be a point to where it gets to. So what do we mean by keeping it light but not simple? This is a very dangerous thing to do, to try and experiment in a situation where lots of people are watching you. But I'm going to do this everywhere. Anyway, this is an experiment that's in my book, Science in the Beginning, I think. And I'm trying to talk about wind and how wind forms. You know, and that's especially thinking yesterday. It's important to know how wind forms. So we all know what this is, right? All right. Now, I hope I don't offend anybody, but I'm going to cut this tea bag and dump out the tea. And we're going to throw that tea away. I know. Don't come up at me and with your pitchforks and so forth. All right. I really do hope this works. Okay. So now we have a tea bag that's a cylinder. So I've just cut the part that's stapled together off, and now I have a cylinder with the tea bag. I'm going to stand this guy up and hope that the wind currents in the room don't knock him down, because that's the biggest thing that goes wrong here. Yeah, okay, let's try the other side, see if it stays up better. The wind currents in the room can be devastating to this experiment. Now I'm probably breaking some sort of safety code, but I'm going to light this thing. Okay, and it's going to burn. Nobody's surprised by that. All right? Did that surprise you? And this isn't going to start a fire because at this point it's completely cool. because once the embers go from red hot, it's completely cool. Okay, that actually tells you how wind forms. Because what happened is, in that experiment, the tea bag where it was burning got very hot. And so the air around it got hot. What does hot air do? It rises, okay? Now, since there's plenty of air around, some air decided to go in and take the place of that air that just left. Well, obviously that was the colder air below. So what that burning did at the top was it started creating a wind that was going from the bottom of the tea bag to the top. Now, at first, the tea bag was kind of heavy because there was still a lot of bag to it. So that wind wasn't strong enough to make it fly. But eventually, we got to the point where the tea bag got light enough that the wind was enough to blow it up. And then once it got up in the air, it got caught in all the other winds that are going on here. But what this demonstrates is that wind is caused by temperature differences. And that's what causes the winds on the earth. The sun heats different parts of the earth differently, and as a result, some parts get warmer, some parts get colder, and the warm air rises and the cooler air moves to take its place, right? That's what I'm talking about, keeping it light but not simple. Learning about how wind is formed is very important, but we don't have to go through all the details yet of cold front and warm front and how cold fronts move under warm fronts and cause them to rise. That's too much yet. But we can do the simple thing that tells them how it forms to begin with. And honestly, in my mind, especially in the early years, these kinds of hands-on activities where students are actually seeing things happen, those are much more valuable than what you're picking up in a textbook. The books I wrote, Science in the Beginning, Science in the Ancient World, they have experiments like this in them, right? I think this kind of experiential science is very good for the primary years. It keeps it light, but not simple. You emphasize discovery by doing experiments. You emphasize discovering things. But here's the big one, especially in the elementary years, there are no set topics to cover in science. Honestly, if your child is wild about bugs, he could study bugs for 6 years in the primary years. I really don't care. Because in the end, the primary years are about learning how science is done. And that can be done in any topic. It really can be. So I know we all have these ideas, and in math it's very true, that by the time they reach this age, they need to know this stuff. That becomes true in science later on, but not in the early years. In the early years, don't worry about whether they're getting enough of this or enough of that. In the end, just make sure they're learning the process of how science is done. And most importantly, working on their math. That's what you're looking for. So my experience, and this is just my experience as an educator, I haven't done any studies or anything like that, is that students coming out of elementary school are best prepared for higher level science if they have a lot of enthusiasm about science. What they've learned, the specific things they've learned, is not nearly as important as whether they enjoy science. So in the end, especially in the early years, get out of this memorize, regurgitate idea, because that's what students hate. Right? There's plenty of opportunity to memorize in other subjects and so forth. I'm not saying don't memorize. But in science, I don't think that's crucial. In the end, we're talking about learning about discovery, developing some amount of enthusiasm to get them through the higher level science. Once you get to the higher level science, math becomes even more important because there are certain math skills that are absolutely necessary to do good science. Right? Now, I know this is funny to you guys. Oh, no. One thing I put in the American, I thought it was still here. In the American slide, I have to put metric units. Because even England doesn't use imperial units anymore, but we still do. Okay, I got rid of it because I knew I was coming to South Africa. So for biology, you don't need to know a lot. You need to know basic arithmetic and things like that. But once you get to chemistry, the student has to know algebra. Now, they don't have to be experts at algebra. They don't have to, generally speaking, some introductory algebra course they need to have completed before they start chemistry, because there are certain arithmetic and algebraic concepts that are absolutely necessary to learn real chemistry. And if you don't know them, either you fail real chemistry or you take some dumbed-down version of chemistry that's not chemistry at all. Because chemistry is inherently mathematical. So, for example, you need to know that when I'm multiplying fractions and I find like terms in the numerator and denominator, those cancel. Now that's real simple arithmetic, right? That shouldn't be a surprise to any of the adults here. Nevertheless, if you really understand this, and if you can make things work that way, so you're looking for like terms in the numerator and denominator, you've actually mastered 35% of high school chemistry. This is 35% of high school chemistry right here. There's one of my chemistry students nodding her head. Yes, of course. This is the factor label method, which is absolutely essential for chemistry. But it's just simple fractions if you can do it and if you can look for it properly. You need to know how positive and negative numbers add, subtract, multiply, and divide. You need to be able to manipulate exponents. So if I got the same number with different exponents and I'm multiplying, I add the exponents. If I'm dividing, I subtract the exponents. You need to know algebraic manipulation. So you need to know if PV equals nRT, then n equals PV over RT. You need to be able to do that manipulation. And this is actually, this is the chemist's favorite equation. We lovingly call it the pervert equation. And it describes how a gas behaves under certain ideal conditions. But the key is, and this is just a lovely equation, because pressure is, if you're doing the experiment in the lab and so forth, it's most likely atmospheric pressure. And you may measure that with a barometer, right? Volume is just how big the container is. If it's square, you can use a ruler to measure that. R is an experimental number that's already been measured. You just look it up in a book. T is temperature. You measure that with a thermometer, all right? N tells you how many atoms are in the sample. Now, we can't see atoms. Even the most powerful telescope in the world, we can't see them. However, with a thermometer, a ruler, a book, and a thermometer, we can count them. Isn't that astounding? You can count something you don't see with some very basic equipment if you know this equation and the algebra that allows you to rearrange it. So anyway, that's my little preaching on chemistry. You also need to know that in this graph, we have an independent variable and a dependent variable. And in this particular, these set of three graphs, it's the red graph that has a maximum, and the maximum occurs at 75 in the independent variable and about 90 in the dependent variable. You need to be able to look at a graph and read like that. You need this kind of stuff just to do chemistry. If you go on to physics, things get better or worse, depending on your point of view. Because at this time now, you do need to know basic trigonometry. Most math courses cover this in their geometry book, later in the book. Some don't cover it till later, but most cover it in geometry. So if I have a right triangle, and I have one side of the triangle, the other side of the triangle, there's the hypotenuse, and the Major General can tell you many interesting facts about the square of that guy, and the angle. I can be given two of these and figure out everything else using trigonometry, because I know that the opposite of the angle is the hypotenuse times the sine of the angle. The adjacent is the hypotenuse times the cosine, and the ratio of the opposite to the adjacent is the tangent. If you don't understand that yet, that's all right. You're going to cover it, right? So you'll get there. But that's what you need to do physics, because this is the basis of what we call vector addition. And if you keep teaching physics without vectors, you're lying to students, because physics doesn't exist without vectors. So this is absolutely essential for studying physics. I'll tell you what advanced means in a minute. Don't worry about that. If you go on and take something advanced in chemistry, you have to have finished Algebra 2, because you have to know what a logarithm is, right? And you have to know, if I say log of x equals 3, you have to know why x is 1,000. You also need to know how you manipulate them. So the log of xy is actually the log of x plus the log of y. And you understand that if you do Algebra 2, hopefully. If you go on to advanced physics, you have to get up to and through pre-calculus, because you need to know what functions are and how those act in the real world. So those are standard math stuff you need to do basic sciences. So in general, you do the sciences in the order that is best for the math. And honestly, if your student's really not into science and is probably doing something else, that's all you need. You need biology, chemistry, and physics. So that could take all of your high school years just doing those three. If your student's science-oriented, this is where the advanced stuff comes in. Because generally we talk about biology, chemistry, and physics as what we call university preparatory courses. So if you take a good biology course in high school, you're going to get about 60% of what you're going to see at a university course. And that will allow you, once you get to university, to have a basic foundation, so you only have to learn the new stuff. If you're student science oriented and thinking about going to university, it's good to take an advanced course to get an idea of what university level is. So an advanced course covers the rest of university chemistry, of science. So if I take biology and then advanced biology, or chemistry and then advanced chemistry, those 2 years in high school add up to 1 year in university. So if you do both of those courses, you've covered everything you would cover in your first year university course. So that's what advanced means. It just means turning the high school course into a university course. There's a big star here because depending on what math you're doing, it may take a while to get to that trigonometry. Just remember, don't start physics until they've seen that right triangle and know how to use the trig for that. So anyway, that's my view of what you do with science. But the key, more than anything else, rather than the years or anything, the key is the order. You start with the science that uses the least math, and you go to the science that uses the most math.